factors affecting the rate of chemical reaction. The third factor here is the effect of temperature. The rate of reaction is directly proportional to any rise in temperature. The rise in temperature here, my dear student, leads to what? Leads to increase the kinetic energy of the molecule of the reactants. So increase the velocity of the molecules, and the rate of collision between them also increase. And so reach the activation energy of the molecules to break the bond between the atom of the reactants with the amount of energy enough to break these bonds, and so the rate of chemical reaction increases. So we have give reason in this point, my dear student. In summer, food goes rotten quickly if we left it in the air, because in summer the temperature rises and this speeds up the rate of decomposition reactions in the food. Therefore, food spoils and goes rotten quickly. Another give reason in this point. Food is cooked quickly in the pressure cookers that we call presto, because the pressure of the water vapor increases, causing an increasing in temperature through short time, so the rate of reaction required for cooking increases. Now, my dear students, we have to know what do we mean by the activation energy. It is the minimum amount of energy required to begin the chemical reaction, or you can say it is the minimum amount of energy gained by a molecule to react at collision. So the activated molecules means the molecules which have kinetic energy that equals or exceeds the activation energy. So my dear students, we have to know what do we mean by the collision theory. It assumes that the reactant molecules must have minimum amount of energy that we call activation energy to collide with each other for breaking the bonds in the reactant molecules, so the chemical reaction occurs or takes place. My dear student, notice that rising temperature for about 10 degrees Celsius makes to double the rate of chemical reaction. Now, my dear students, we are going to discuss the fourth factors that affect the rate of the chemical reaction, which is the effect of pressure. If the reactants or products found in the gaseous state, we express them by using their molecular partial pressure. For example, the preparation of ammonia gas in industry, as the reaction proceeds on the screen, nitrogen plus hydrogen gives ammonia gas in the presence of high pressure and temperature then cooling. Here the reaction is exothermic, giving delta H equal negative 92 kilojoule. In this reaction, 4 moles for the reaction, 4 from أعجبنى. In this reaction, my dear students, 4 moles from the reactants, 1 mole of nitrogen and 3 moles of hydrogen react to form 2 moles from the product, which is ammonia gas. And so the formation of ammonia gas is accompanied by decrease in the number of moles and so decrease in their pressure. So, my dear students, we have to define what do we mean by the equilibrium constant Kb. It is the ratio between the rate constant of forward and backward reaction depending on the partial pressure of the reactants and products. So, my dear student, Kb is used to express the equilibrium constant in the gaseous reactions. So, my dear student, Kb for the previous reaction equals the pressure of the ammonia gas power 2, which is the number of the balanced equation before the ammonia gas in the equation, over the pressure of nitrogen times the pressure of hydrogen power 3, which is also the number of moles of hydrogen in the balanced equation. So, my dear student, we have to discuss some examples about it. Here this example calculate the equilibrium constant Kb for the reaction N2 plus 2O2 in gaseous state forming 2 moles of nitrogen dioxide gas, given that the pressures are 2, 1 and 0.2 atmospheric air for the gases NO2, O2 and N2 respectively. So the solution here Kb equals the pressure of nitrogen dioxide gas power 2 over the pressure of nitrogen times the pressure of oxygen power 2. So Kb here equals 2 power 2 over 0.2 times 1 squared. So equal 20. Now, my dear student, we have give reason in this point. Heating cylinders of butagaz from outside is very dangerous, because heating process converts the butagaz from the liquefied state to the gaseous state. As a result, the volume of the gas increases and causes high pressure on the cylinder walls, leading to its explosion. Now, my dear student, we are going to discuss the fifth factor that affect the rate of chemical reaction, which is the effect of the catalyst. What do you mean by catalyst? Catalyst, it is the substance which causes a change in the rate of chemical reaction without itself being changed. So, catalyst increases the rate of chemical reaction by decreasing the activation energy of the reaction, or decreasing the activation energy for the reactants to form the products. We have give reason in this point. Catalyst does not affect on the reaction equilibrium, because it increases the rate of both forward and backward reaction by the same proportion, so it decreases only the time needed to reach the equilibrium state. So it reaches equilibrium fast. So we have give reason in this point, my dear student. Catalysts have an economical importance because it decreases activation energy of reactants, so increases the rate of chemical reaction, thus it saves a lot of money paid for using fuel to raise the temperature. So, my dear student, the catalyst is an elementary metal or its oxide or its compounds. And we have give reason in this point, my dear student. Catalytic converters are connected as part of the car exhaust system in cars because they change the gaseous combustion products which cause air pollution into safe products. My dear students, what do we mean by enzymes? Enzymes are high molecular weight proteins produced in living cells. These enzymes are used as catalysts in several biological and industrial processes. Now, my dear student, we are going to discuss the last factor which affects the rate of chemical reaction, which is the effect of light. Some chemical reactions are affected by light, such as photosynthesis. Here, what is the role of the chlorophyll in the photosynthesis process? It absorbs the light energy and acts as catalyst to form carbohydrates, to form water and carbon dioxide gas. Now, my dear students, we are going to discuss the photographic films. The photographic film contains silver bromide layer, which is the latinous layer, and when the light falls on such films, the silver ion gains an electron from the bromide ion, exchanging the silver ion into silver metal. Then silver is absorbed by the bromine in the gelatinous layer. When the intensity of the light increases, the rate of formation of silver increases. Now, my dear students, we are going to discuss Le Chatelier principle. It states that change in any of the condition of a chemical reaction at equilibrium, state as concentration, temperature or pressure, the reaction will be shifted in the opposite direction of this change. Now, my dear students, we are going to discuss the factors affecting the chemical reaction at equilibrium. Remember, my dear students, we have two types of factors in this chapter. Factors affecting the rate of chemical reaction generally, and another factors that affect the chemical reaction especially at equilibrium. Here, there are three factors: concentration, temperature, and pressure. We are going to discuss each one in details. The effect of concentration on the equilibrium. Here, we are going to discuss the concentration of the reactants. Increasing the concentration of reactants or decreasing the concentration of the products, the reaction shifts forward direction and it forms products. As a result, the concentration of the reactants decrease and the concentration of the products increase. While decreasing the concentration of reactants or increasing the concentration of the products, this makes the reaction shifts in the backward direction to the direction of formation of reactants. As a result, the concentration of the reactants increase and the concentration of the products decrease. Now, my dear student, we are going to discuss an experiment to show the effect of the concentration on the equilibrium. On adding iron 3 chloride solution that has yellowish color to ammonium thiocyanate, which is colorless solution, the solution becomes red color, and we have give reason for this point. The reason is due to the formation of iron 3 thiocyanate, which has blood red color. As shown on the screen, the reaction of iron 3 chloride that has yellowish color to the ammonium thiocyanate, which is colorless, it gives iron 3 thiocyanate, which has blood red color, releasing or giving ammonium chloride solution. When adding excess of iron 3 chloride solution, the intensity of the red color increases. So the observation here, the red color intensity increases on adding excess of iron 3 chloride. And so we have give reason in this point. The reason is, according to Le Chatelier principle, when the concentration of the reactants increase, the reaction shifts in the direction of formation of the products, and so in forward direction the reaction shift, so forming excess amount of iron 3 thiocyanate, that means the red color intensity increase. My dear student, on adding excess ammonium chloride, the intensity of the blood red color decreases. Here we have give reason in this point. The reason that, according to Le Chatelier principle, when the concentration of the products decrease, the reaction shifts in the backward direction, so the decreasing of the amount of iron 3 thiocyanate, so the red color intensity decreases. Now, my dear student, we are going to discuss the second factor which affect the rate of chemical reaction at equilibrium, which is the effect of temperature. Here, we are going to discuss first if the reaction is exothermic. What do we mean by exothermic reaction? It means the reaction that gives heat as a product of the reaction. As shown on the screen, reactants give product plus heat, or we can express it by reactants minus heat give product, or we can express it as reactants give products and delta H is negative. Here, the increase in temperature shifts the reaction in the backward direction according to Le Chatelier principle. And so, the decrease in temperature shifts the reaction in the forward direction according also to Le Chatelier principle. While, my dear student, if the reaction is endothermic, what do we mean by endothermic? Here, the reactants absorb heat to give the products. As shown on the screen, reactants plus heat gives the product, or we can say reactants gives the product minus heat, or reactants give product and delta H is positive. Here, the increase in temperature shifts the reaction in the forward direction according to Le Chatelier principle, while the decrease in temperature, it shifts the reaction in the backward direction, also according to Le Chatelier principle. Now, my dear student, we are going to show an experiment to show the effect of temperature on the equilibrium. As shown on the screen, get a flask containing nitrogen dioxide gas, which has reddish brown color at room temperature. The equation shows nitrogen dioxide gas that forms dinitrogen tetraoxide and gives heat. This reaction is exothermic by its nature. So, when heating or cooling, we are going to shift the reaction in the forward or backward direction, and we are going to show this in the following animation. My dear student, here we have to bring 3 test tubes, and we are going to put the first one in hot water, and we are going to show what happens by heating the nitrogen dioxide gas that is in equilibrium with dinitrogen tetraoxide, and then we are going to put it in cold water to show the effect of the temperature. Here, the reaction shifts to form nitrogen dioxide gas, and this is on heating, and by cooling, the reaction shifts in the direction of form dinitrogen tetraoxide, which is colorless, and so the reaction here shows the effect of the temperature on the equilibrium. Here, the reaction shifts to form more nitrogen dioxide by heating and forms dinitrogen tetraoxide on cooling, and so shows the effect of increasing or decreasing temperature on the reaction. So, my dear student, when the flask is cooled, it becomes colorless, as the reaction shifts in the forward direction, forming dinitrogen tetroxide. As the equation proceeds, here 2 moles of NO2 that has reddish brown color, that on cooling forms dinitrogen tetraoxide, which is colorless and gives out heat. And when the flask is in hot water, it becomes reddish brown color, as the reaction shifts in the backward direction, forming more NO2 gas. Here, as the equation proceeds on the screen, the dinitrogen tetraoxide plus heat, it changes into 2 moles of nitrogen dioxide, which is reddish brown gas. Now, my dear students, we have to show the relation between the effect of temperature and Kc in the exothermic and endothermic reaction. If the reaction is endothermic, according to Le Chatelier principle, the increase in temperature shifts the reaction in the forward direction, so the concentration of the product increases. So this leads to the increase in the equilibrium constant Kc, and vice versa. So we can say the temperature and Kc are directly proportional to each other. This takes place in endothermic reaction. So, my dear student, if you are asked about to decide the reaction is endothermic or exothermic, you have to show the relation between the temperature and the Kc of the reaction. If the temperature increases and Kc also increase, this means the reaction is endothermic. While if the reaction is exothermic, according to Le Chatelier principle, the increase in temperature shifts the reaction in the backward direction, so the concentration of the product decreases, and so leads to decrease in the equilibrium constant Kc, and vice versa. So if the temperature increase, Kc decrease, so they have inversely relation to each other. So My dear student, if you are going to be asked about the type of the reaction is exothermic or endothermic, you have to show the relation between the temperature and the Kc. If the temperature increase and Kc decrease, so this type of the reaction is exothermic reaction. While if they are direct relation to each other, so it will be endothermic reaction. Now, my dear student, we are going to discuss the last factor which affect the reaction at equilibrium, which is the effect of pressure. My dear student, if the substance which enters the reaction and the resulted from the reaction found in the gaseous state, we express them by using their partial pressure. So, if the number of the moles or volume of the reactants equals the number of moles or volume of the products, the pressure has no effect on the equilibrium. For example, the reaction between carbon monoxide and water vapor gives carbon dioxide gas and hydrogen gas. Here, 2 moles from the reactants react to form 2 moles of product. So, by increasing the pressure, by decreasing the volume of the container, here, or decreasing the pressure by increasing the volume of the container, the pressure has no effect on the equilibrium position. While if the number of moles or volume of reactants are greater than the number of moles or volume of products, here the increase in the pressure by decreasing the volume of the container, the reaction shifts to forward direction according to Le Chatelier principle. So the concentration of the reactants decrease while the concentration of the products increase. This means Kc will be increased. Now, if the decrease in pressure that takes place by increasing the volume of the container, the reaction shifts in the backward direction according to Le Chatelier principle. So the concentration of the reactants increase while the concentration of the products decrease, so Kc decrease. Here, my dear student, in the example shown on the screen, N2 plus 2O2 gives 2NO2 gas. Here, 3 moles from the reactant react to form 2 moles from the products. So, the increase in the pressure, my dear student, by decreasing the volume of the container, shifts the reaction in the backward direction according to Le Chatelier principle, so the concentration of nitrogen and oxygen gas decreases while the concentration of nitrogen dioxide increases. While the decrease in the pressure by increasing the volume of the container shifts the reaction in the backward direction according to Le Chatelier principle. So the concentration of nitrogen and oxygen increases while the concentration of nitrogen dioxide decreases. My dear student, if we have a reaction that the number of moles or volume of the reactants is less than the number of moles of the products, that means the increase in pressure by decreasing the volume of the container shifts the reaction in the backward direction according to Le Chatelier principle. So the concentration of the reactants increase while the concentration of products decreases. My dear student, the decrease in pressure in this reaction by increasing the volume of the container shifts the reaction in the forward direction according to Le Chatelier principle. So the concentration of reactant decreases and concentration of products increase. For example, my dear student, the nitrogen dioxide gas on decomposition giving nitrogen and oxygen gas, 2 moles from the reactants react to form 3 moles of the products. So the increase in the pressure or decrease the volume of the container, here the reaction shifts in the backward direction according to Le Chatelier principle. So the concentration of nitrogen and oxygen decreases while the concentration of nitrogen dioxide gas increases. Here, my dear student, while the decrease in pressure or increasing the volume of container, the reaction shifts in the forward direction according to Le Chatelier principle. So the concentration of nitrogen and oxygen increase while the concentration of nitrogen dioxide gas decreases. My dear students, we are going to discuss some questions on these points. My dear student, examine the following reaction. H2 plus CO2 gas gives H2O plus CO minus heat. Here, what is the effect of the following changes on the concentration of hydrogen gas? Adding carbon dioxide, adding water vapor, adding catalyst, rise of temperature, decrease of pressure, adding potassium superoxide. Here the solution, my dear student. On adding carbon dioxide gas, the reaction shifts in the forward direction according to Le Chatelier principle, so the concentration of hydrogen gas decreases. On adding water, my dear student, it shifts the reaction in the backward direction according to Le Chatelier principle, so the concentration of hydrogen gas increases. Adding catalyst, my dear student, it increases the rate of both backward and forward direction by the same proportion, so it decreases only the time to reach the equilibrium, so it doesn't affect on the concentration of hydrogen gas. The rise of temperature, my dear student, as the reaction is endothermic, so the increase in temperature shifts the reaction in the forward direction, so the concentration of hydrogen gas decreases. Here, the decrease in pressure, my dear student, as the volume or the number of moles of reactants equal the number of moles or volume of products, so the pressure has no effect on the equilibrium, so it doesn't affect on the concentration of hydrogen gas. Adding potassium superoxide, my dear student, it reacts with carbon dioxide gas, so decreasing its amount. That means the reaction shifts backward direction of the reaction, so forming hydrogen and carbon dioxide gas, so concentration of hydrogen increases. My dear students, we have reached to the end of our program today. I hope you understood the points that we discussed today and different types of problems. So till we meet again, my best wishes for you.